So good morning all. Welcome for the next lecture for the hydrology and water resources engineering. We are discussing about the soils and crops. And in the last lecture, we have discussed about the numericals associated with the available moisture for the crops. That is, in that we had seen what does it mean by the optimum moisture content. Then also we had seen that when to say sorry, how to calculate the number of the days after which we will be required to go for irrigation, or the irrigation frequency we can say. Those things we had seen in the previous class. This example also we had seen. It is the dry unit weight and all those things. Those examples are so much essential because these were asked in the examinations of IES and all those things. Examinations like IES. That one of the example we had seen last time, which was asked in a IES examination, that I would like to go for. Uh, Firstly, that we had solved last time, but once again we'll go for the quick review of that, and then we'll start for the next part. This limiting moisture content and all those things we were discussing about. Okay, this one also we have solved. This example also we had solved last time only. Sorry. Huh. This was the asked it for the engineering services in 1974. I will go for a quick review because we are starting the lecture after a gap. Okay, so that we will get an idea. So after how many days will you supply the water to the soil in order to ensure the irrigation of a given crop if the field capacity of the soil is 28%, permanent wilting point is 13%, dry density of the soil is 1.3 gram per cc, assuming daily consumptive use of a water for the given crop is a 12 millimeter and the effective root zone depth as a 70 centimeter. It was asked in engineering services for 1974. So we'd have to go for firstly the data which is given to us over here, what they had asked and what they had given. They are asked after how many days will you go for supplying the water to the soil. Means after how many days we will be or you will go for the providing the water or irrigation to the crop. Why? Because we have to maintain the turbidity of the crop, or the whatever the growth of the crop is there, we have to maintain it. For that purpose, after how many days we will be required to go for. That means frequency of irrigation they have asked. And for that, they had given the data as field capacity of the soil as a 28%. Okay. Then permanent wilting point 13%. It is wilting coefficient we can say. Dry density of the soil 1.3 gram per cc, and the daily consumptive use of the water for the given crop is a 12 millimeter. It means that the water which is required for the crop for its all these, that is evapotranspiration we can say, that is evaporation, transpiration, etc. consumptive use, that is it is a 12 millimeter. म्हणजे प्रत्येक दिवसाला त्या क्रॉपला 12 मिलीमीटर एवढ्या पाण्याची गरज आहे. And effective root zone depth is a 70 centimeter, and the crop ची root zone ची depth आहे that is up to a 70 centimeters. Okay, so the given data here: field capacity 28%, wilting coefficient that is a 13%, gamma d that is a dry unit weight or a dry density of the soil as a 1.3 gram per cc, that is cm cube we can say. And on the same language, that is on the same units, the unit weight of the water is a 1 gram per centimeter cube. Then consumptive use cu, that is 12 millimeter. I have converted to the cm because all the units are here in the two units are in centimeters, so that converted to the centimeters, that is 1.2 centimeter. And the root zone depth, that is a small d, is a 70 centimeters. And what they asked to calculate the time of irrigation. Okay, that is asked to calculate. Then we know from the equation, that is a frequency of irrigation, that is a time t we can say, there's a dw upon consumptive use, where dw is nothing but the uh, moisture content which is available in the root zones, which will be absorbed by the soil, and divided by a consumptive use. So for finding out the dw, will be required to calculate the optimum moisture content. That is, for dw we need to calculate the optimum moisture, which is nothing but the field capacity minus readily available moisture. And that readily available moisture used to exist in between is about the 80% of the available moisture. It means firstly we will be required to calculate the available moisture. So how to go for that, we will see now. Assuming readily available moisture up to the crop is 80% of available moisture, means whatever the moisture used to be there in the soil, out of that out of that readily available out of that moisture, available moisture, we can say the 80% will be available to the crops. We are assuming that. So from that line, that is available moisture to the crop as 80% of the, okay, then means whatever the moisture used to exist between the field capacity and wilting coefficient, that is we treat as an available moisture. जी काही मॉइश्चर किंवा जे काही पाणी त्या जमिनीमध्ये किंवा त्या सॉइल मध्ये फिल्ड कॅपॅसिटी आणि विल्टिंग कोइफिशियंट या दोन लिमिटच्या मध्यंतरी असणार आहे, ते म्हणजे अवेलेबल मॉइश्चर असते. अँड आउट ऑफ दॅट अवेलेबल मॉइश्चर, जी रेडिली अवेलेबल मॉइश्चर जी राहते ती 80% आपण अज्युम करतोय. क्लिअर? इथं एक्झाम्पल मध्ये दिलेलं नाहीये म्हणून आपण 80% अवेलेबल करतो, अवेलेबल असं अज्युम करतोय. जनरली इट इज अबाउट 70 to 80%. Okay, but we are assuming here it as an 80%. देन आउट ऑफ दॅट, म्हणजे हे मिळाल्यानंतर ना जी ऑप्टिमम मॉइश्चर कंटेंट जी राहते ती कुठेपर्यंत राहते, तर फिल्ड कॅपॅसिटी म्हणजे अप्पर लिमिट अवेलेबल मॉइश्चरचं आणि जी आपली 80% जी राहते कोणाची अवेलेबल मॉइश्चरची, त्या दोघांचं सबस्ट्रॅक्शन केल्यानंतर जी मॉइश्चर कंटेंट अवेलेबल होतो तो म्हणजे आपला ऑप्टिमम मॉइश्चर कंटेंट राहतो. सो विल सी दॅट नाव. Now, available moisture to the crop is we are knowing, that is field capacity minus wilting coefficient. Here field capacity is a 28%, that is a 0.28 minus the wilting coefficient is a 13%, that is a 0.3, sorry 0.13, and it accounts to a 0.15, means 15% is a available moisture to the crop, we can say. Now out of that readily available will be 80%. So the readily available moisture is a 80% of available moisture, that is 80 by 100, means 0.8 into available moisture, that is a 0.8 into 0.15, that is equals to 0.12, means 12% is a readily available moisture, we can say. Now from that we will get the optimum moisture, which is which can be extracted by the root zones of the crop so easily. Okay, so now for that we will get from this equation, mo is equals to field capacity minus readily available moisture, that is a 0.28, that is a field capacity which is given to us, minus readily available moisture we have calculated as a 0.12, so it is equals to 0.16. So now we got the optimum moisture content, that is a 16% out of the whatever the field capacity and wilting coefficient is there. From that 16% is a optimum moisture. Now from that we have to calculate the dw. So now how to get the dw? Now for the dw we are knowing the relation gamma d by gamma w, that is gamma d is nothing but the dry unit weight of the soil, and gamma w is the dry unit weight of the water, or the unit weight of the water, we can say, sorry, unit weight of the water, into d is the depth of the root zone into field capacity minus optimum moisture content, that is equals to gamma d is a 1.3 into depth of the root zone is a 70 centimeters into field capacity as a 0.28 minus 0.16 as optimum moisture content by 1. That gives us a dw 10.92 centimeters. Believe me that we have solved this numerical lastly in the previous class, but as an part of the revision I am taking once again this one. Okay, then from this dw we have to find out the frequency of irrigation, that is after how many days we have to go for, that is frequency of irrigation is equals to dw by consumptive use, we can say. That is now frequency of irrigation, that is the days after irrigation will be carried out, is given as frequency of irrigation is equals to dw by a cu. Dw is a depth of the water which is available for the crop, isn't it, which is having the its root zone depth as a 70 centimeter, is a 10.92 centimeters, which you have calculated, divided by consumptive is 1.2. It means that whatever the moisture is there in the soil, out of that 10.92 centimeter moisture, depth of the moisture is available for this for that crop which is having the depth of the root zones as a 70 centimeters, isn't it? So now out of that 10.92, the crop is going to have, or crop is going to utilize 1.2 centimeters per day. त्या क्रॉपची रिक्वायरमेंट किती आहे कन्झम्पटिव्ह यूज साठी, म्हणजे वेगवेगळ्या मेटाबॉलिक ऍक्टिव्हिटीज असतील, इव्हॅपो ट्रान्सपिरेशन असेल, इव्हॅपोरेशन असेल, हे सर्वच्या सर्व होण्यासाठी 1.2 सेंटीमीटर्स एवढं त्याला दिवसाचा गरज आहे. म्हणजे याचा अर्थ काय, इफ इट इज गोइंग टू कंझ्युम 1.2 centimeters per day, then 10.92 will be utilized in how many days, and after getting full utilization of a 10.92 centimeters will be required to go for irrigation. So that I have divided the 10.92 by 1.2 over here. That yields the value as a 9.1 days. Means after 9.1 days, that moisture will be get vanished. जी काही मॉइश्चर असणार आहे ती मॉइश्चर पूर्णपणे तिथून ती व्हॅनिश होणार आहे. मीन्स विल बी रिक्वायर्ड टू गो फॉर इरिगेट द सेम आफ्टर 9.1 days. But 0.1 days is so less. So means we will assume that, or we will go for the irrigation after 9 days only. म्हणजे बरोबर इरिगेशन सॉरी फर्स्ट इरिगेशन केल्यानंतर ना आपण बरोबर 9 दिवसाने नंतर पुन्हा त्याला आपल्याला इरिगेशन करावं लागेल. Isn't it? No. So that is about this example which we have solved in a previous class. Now this is the next one. Please note down the same immediately, which was asked in December 14 for 7 marks for the Solapur University examination. The following data pertains to the healthy growth of a crop. Means the data which is given over here is associated with the healthy growth of a crop, which includes the field capacity of the soil as a 30%, permanent wilting point 11%, density of the soil 1300 kg per meter cube. Here the unit is kg per meter cube. So we'll be required to consider the density of the water on the same lines only. Then effective depth of a root zone is a 700 millimeters. Daily consumptive use 12 millimeter for a healthy growth. Moisture content must not follow below the 25% of the water holding capacity and the permanent wilting point. It means they had given us the limit as 25% instead of the 80% which you have assumed in a previous example, which was asked for the engineering services examinations. Okay, so here instead of 80% will be required to go for a 25%. And what they asked, determine the watering interval in a days, means after how many days will be required to go for irrigation, that is asked. So please note down the example immediately, solving it. Okay, now for the given data, from the given example, the following data pertaining to the healthy growth of a crop, that is field capacity of the soil is 30%. So field capacity, okay, let it become chalo. So given data, field capacity is 30%. Then density of the soil they are given as a 1300 kg per meter cube. This is here in, instead of 1.3 they are given as 1300 kilograms per meter cube. Okay, kg per meter cube. So the density for the water, it will be now in the same units, that is a kg per meter cube. It will be 1000, isn't it? बरोबर आहे का बघा, 1000 meter cube. Use is given to us. How much they had given? Consumptive use, consumptive use 12 millimeters. So 12 millimeter, that is 1.2 centimeters. Then root zone depth D they had given us, that is a, where is it, 700 millimeters, that is a 70 centimeters. Will go for 700 millimeter, that is equal to 70 centimeters. How come it will be, 7 centimeters, no? बरोबर आहे, hundreds, it is a 70 centimeters. Then what they are given us again, wilting coefficient 11%, wilting point as 11%. Along with that, they had given us the moisture content must not follow below the 25% of the water holding capacity and the permanent wilting point, isn't it? Means what they had given us, they had given us for optimum moisture content, sorry, this parameter where we have calculated this one. There is a readily available moisture is a 0.8% of a available moisture. So we'll mark here in readily available moisture. They are given, so let's let it be now. Whatever they had given us, readily available moisture is a 25% of available moisture, isn't it? This is the data which is given to us. And what they asked to determine the watering interval in a days. That is a frequency, we can say. That is a watering interval. That is time of irrigation or the frequency of irrigation, we can say. Frequency of irrigation they have asked to calculate. Okay, now we'll go stepwise. We know that frequency of irrigation directly by formula. Frequency of irrigation is equals to dW by consumptive use. Okay, dW is the moisture which is available by considering optimum moisture content and all those things for the crop for that particular root zone depth of 70 centimeters. So now for dW, we will be required to calculate the optimum moisture content, which is field capacity minus readily available moisture. And the readily available moisture is they are given us 25% of available moisture. Okay, so they had given us the readily available moisture to the crop is about 25% of available moisture. Okay, how 25% I'm writing here? Because they have given us the moisture content must not follow below 25% of the water holding capacity. Okay, and the permanent wilting point means field capacity and permanent wilting point, that moisture is to consider as a available moisture. आणि याच्या दोघांमधली जी मॉइश्चर कंटेंट असणार आहे तिच्या 25% खाली जायला नाही पाहिजे. म्हणजेच रेडिली अवेलेबल मॉइश्चर कंटेंट जो आहे तो 25% ऑफ द readily available moisture असायला पाहिजे आहे. Answer I don't know because I have not solved this. We will go for that one. Okay, so then available moisture content, field capacity minus wilting coefficient. Field capacity is a 30%, that is a 0.3 we can write over here, minus the permanent wilting, that is a 11, that is 11%, that is a 0.11 we can say. Okay, so 0.30 minus 0.11, that is nothing but the 0.19 or 19% we can say, that is available moisture. Then from that we will be able to now calculate the next parameter, that is the readily available moisture, that is a 25%, means 0.25 of available moisture, that is a 0.25 into 0.19, 0.25 into 0.19, that is 0.0475. This is a readily available moisture, means without any efforts, without any additional suction force, the crop will be able to absorb that moisture, we can say. So the optimum moisture content will be now the field capacity minus readily available moisture, means the lower limit of the field capacity we are going to calculate over here. 3 points. Okay, we will check that what is the answer. Okay, optimum moisture content is equals to field capacity minus readily available moisture. Field capacity is given to us as a 30%, so 0.3 minus readily available moisture is a 0.0475. Okay, so 0.3 minus 0.0475, that is equals to 0.2525. 0.2525. This is the lower limit we can assume over here. In that is optimum moisture means the lower limit of the field capacity, that is out of readily available moisture. Now from this we have to find out the frequency of irrigation. Now we have calculated the optimum moisture content over here. Now we'll go for the next part. Okay, so here for dw using the relation, this answer is for the previous example, not for this one. dw into d into fc minus mo divided by gamma w. Now the gamma d they are given us as a 1300. Believe me that whatever the unit is there in, that will get cancelled to each other. Gamma w is 1000. Clear? Then the depth of the root zone is a 70. Field capacity is a 30%, so 0.3, and optimum moisture content is a 0.2525. 0.2525, isn't it? So just calculate the value. There is 1300 into 70 into 0.3 minus 0.2525 upon 1000. That is a 4.3225 centimeters. That is a dw we can say. That is the depth of the water we can say, which is available to the crop by considering the lower limit as a mo, upper limit as a field capacity, and the depth of the root zones as a 70 centimeters. Now frequency of irrigation, that is the days after irrigation will be carried out, that is given as dw by cu. Just to put up the values over here. So the dw we have calculated it as a 4.3225 upon the magnitude for the consumptive use they had given us as a 1.2 only. That is the same as like in a previous example. So the ratio is by 1.2. It gives us as a value of magnitude as a 3.6 days, isn't it? The magnitude as a 3.6 days. Now whatever the answers I got over here in, okay, 3.6 days. So the frequency of irrigation will be now 3.6 means we will go for 3 days. Means after 3 days, without waiting to moisture content to go below the 25% of the available moisture, we'll go for the irrigating the crop, so that its a turgidity and all those things will be maintained as it is. Okay, so go for this one. The sufficient irrigation water is to be applied to the crop. Calculate after how many days you will supply water to the crop based on the following data. Field capacity of a soil 29%, permanent wilting point 14%, dry unit weight of a soil 12.75 kilonewton per meter cube, unit weight of a water 9.81 kilonewton per meter cube, effective depth of the root zone 70 centimeters, and daily consumptive use of water for the given crop is at 12 millimeters. Okay, it was asked in December 16 for 7 marks. So the given data, field capacity is at 29%. So here instead of 30%, we'll go for a 29%. Okay, 9 days. Okay, 9 days. The answer you got. Okay, others please do solve. I don't know the answer because I have not solved this. Okay, so now we'll go for the solving. Just check it. Field capacity of soil is 29%. Then wilting coefficient, how much they had given us? Wilting coefficient as a 14%. That is a 1.4 we can say. Then gamma D, that is a dry unit weight of a soil 12.75. It's a 12.75 kilonewton per meter cube, and that for the water is a 9.81 kilonewton per meter cube. 9.81 kilonewton per meter cube. Then what else? Effective root zone depth 70 centimeters as usual, which we have considered in the previous example also. This is a 70 centimeters. Then daily consumptive use, that is a 12 millimeters, so that is a 1.2 centimeters. Okay. Now what they asked to calculate, how many days after you will go for the irrigation, that is the frequency of irrigation, water interval or frequency of irrigation. Now I will solve for. So now we are knowing the frequency of irrigation is a dW by Cu, that is the depth of available moisture, we can say, upon the consumptive use. But that depth of available water or moisture is based on the optimum moisture content. Okay. So for dW we are knowing, we'll require to calculate the optimum moisture content, which is field capacity minus readily available moisture. But here they had not given us that what is the magnitude. Okay. So we're assuming that the available readily available moisture is 80% of available moisture. Okay, so available moisture we are knowing field capacity minus wilting coefficient. Field capacity is 29%, so 0.29 minus wilting coefficient is a 14%, that is a 0.14. It is a 0.29 minus 0.14, that is a 0.15, we can say. Okay, so this is a available moisture. Now out of that, readily available moisture means we have calculated the difference between field capacity and the wilting coefficient, which gives us an available moisture. Now out of that, readily available moisture, we are assuming it as 80%. So readily available moisture is a 80%, that is a 0.8, we can say, into available moisture. So that is 0.8 into 0.15, that is a 1.5. So 0.15 into 0.8, it gives us a 0.12. This is the magnitude here that we can consider as an readily available moisture. It is a only a 12%. Okay, means out of that 15% available moisture, readily available is only 12%. Now the optimum moisture content, we can say, that is nothing but field capacity and it's a lower limit, that is field capacity minus readily available moisture. So field capacity is a 29%, that is a 0.29 minus 0.29, where is it? 0.29 minus the readily available moisture, that is a 0.12, that is a 0.29 minus 0.12, that is a 0.17, we can say. It means here the lower limit of the field capacity is a 17%. We are treating it as, isn't it? Now we got the optimum moisture content, we got readily available moisture, etc. Now we have to find out the dW and then frequency of E. Okay, so dW by using the relation gamma d by gamma w into d into fc minus mo. Gamma d 12.75, depth of the root zone 70 centimeters, field capacity is 0.29, optimum moisture content 0.17 by gamma w 9.81. That dW, depth of water, is 10.92, and frequency of irrigation from the given data dW by Cu, we are getting it as a 10.92 by 1.2, that is 9.097 days, means after 9 days we will be required to go for irrigating the crop. Okay, this is the data for this example. Now today we'll stop over here and we'll start our such type of the important numericals in the next lecture.